In this section, we'll cover how to choose who to survey. The information here is general and it can be used for any type of data collection, whether it be a needs assessment survey, a baseline survey, or an impact evaluation. Of course, the best possible solution will be to collect information from every single person who you're interested in. While this may be possible in some special cases, like relatively small projects, usually you'll only have enough resources to collect data from a smaller subset of the population. The method by which you choose this smaller subset of the population can have very drastic effects on the quality of results. The first question we'll address here is it always better to have some data, even if it's imperfect, than have no data at all? In the real world, no survey will be perfect, and that includes the selection of survey participants. So the question then is, when is the data you collect good enough to be useful? In extreme cases, the data collected could be misleading, and it can actually do harm if those misleading results are taken seriously. For example, let's say that you're collecting a survey of women's role in the household decision-making process in an extremely conservative setting like Afghanistan or rural India. If you design a method of sampling households and then ask residents to take the survey, many women might refuse to participate and won't answer the survey questions. This would be especially true if completing the survey involved leaving the house or if survey enumerators were male. On the other hand, more liberal women will be more likely to complete the survey. These women might also differ in other respects, such as their income, occupation, health habits, etc. The results of the survey might make women appear to have more decision-making power than they actually do on average. So is the data collected in this way useful, or will the conclusions just be misleading? If the households were selected randomly, then we at least know the percentage of women who agreed to take part in the survey, and that gives us a clear idea of the degree of the problem. It might be possible to make an educated guess as to why people are missing from the sample. So, as we've already said in this example, it's likely that more conservative women are missing from the sample. If the survey manages to collect data from 85% of the households that were asked to take part, then we might guess that the women from the remaining 15% of households have, on average, less power over household decision-making than the average over the whole population. In other words, the estimate we get from the 85% of households from which women were willing to complete the survey will give us an upwards biased estimate of women's control over household decision-making. On the other hand, there might be other reasons that women didn't answer the survey. Maybe they were too busy. Those women too busy to answer the survey may be more likely to run small businesses or to be socially or politically active. And that might be the reason why they weren't willing to answer the survey. At the same time, those qualities would likely be correlated with greater control over household decisions. And that would bias survey estimates of women's control over household decision-making in the other direction. At the end of the day, though, these are just guesses. we can only be sure about the results from the segment of the population that's willing to take the survey. Who is willing to answer a survey, or the response rate, introduces a bias that we can't really avoid. However, there are a few things that we can do to improve the quality of the data that we collect. First of all, avoid the temptation to use convenient samples. In the previous example, we discussed a survey that looks at women's control over household decision-making. If we conducted a survey using women who are waiting in line at a health clinic, or women selling goods in the market, or self-help group members, this might reduce the costs of gathering data. In other words, it's cheaper than randomly sampling households and sending someone to those households. However, the results of this data collection will have a very low level of generalizability. It won't tell you very much about the population at large. One method of convenient sampling that you might encounter is called snowball sampling. This is a method of data collection in which a small group of individuals is selected to be in the survey in the first round. Then, these individuals are asked to refer others, sometimes meeting a set of criteria, to be surveyed in further rounds. This raises a serious problem. When respondents refer others to be surveyed, they will be more likely to refer others with certain qualities. For example, those who have more free time, or possibly respondents who will only refer others to the survey team that won't embarrass them. So they don't want to admit that they know certain people and they won't refer these people. And that creates a bias in our sampling method. Any conclusions based on the data collected in this way can be very misleading. So now we've gone over a couple examples of the wrong way to choose a sample for the survey. And so now let's go over the right way to choose a sample for the survey. The general principle here is that any method we choose should give each person in the population an equal chance of being selected to take the survey. Before we move on, we should define a couple of terms that we've been using in this discussion. By population, we mean all of the people in whom we are interested. The population of interest varies according to the scope of the study. Maybe we're interested in all of the women who are of childbearing age in northern Uganda, or possibly small business owners living in urban Dhaka. A representative sample is a subset of the population that is selected randomly from the larger population. This means that given the way that the sample is selected, each person in the population of interest has the same chance of being chosen as anyone else. In other words, it means that only random chance determines who is surveyed and who is not. If these criteria are fulfilled and the sample is representative, then the sample mean, or average, can be expected to be the same as the average of that characteristic in the population. If a sample is representative, then as the sample size gets bigger, then we can be more sure that the sample mean is closer to the population mean. This principle is called the central limit theorem, and it's discussed in more detail in the course on statistical methods. The best way to get a representative sample is to make a comprehensive list of all of the people who are members of the population and then randomly select a number of those individuals to survey. If the population of interest is only the clients of a particular program, or if there does exist a comprehensive list of all the residents in a particular area, this might actually be a feasible way of choosing a representative sample. However, if the population of interest includes non-clients, then the sampling strategy is usually going to be a little bit more complicated.